Yeah, welcome everybody to this webinar about TwinCAT Cloud Engineering. My name is Sven Goldstein. I'm product manager for Beckhoff Automation, especially for our TwinCAT automation software and everything regarding connectivity. I'm joined here by my dearest colleague, Michael Knossalla. He's here virtually, so he's in the attendee list, and he'll be there to answer your questions on the fly should you have any questions. So basically, if you have any questions, just use the questions window inside of the GoToMeeting software, and Michael will be pretty busy answering all of your questions. And if there are any open questions at the end of the webinar, we will answer them after the webinar. So you will receive an email from us, and we're trying to answer all of your questions. So this webinar is about TwinCAT Cloud Engineering. TwinCAT Cloud Engineering is our first cloud service, which we have announced on the SBS IPC Drives trade show last year in November. And we've been pretty busy this year developing this cloud service and engineering all of the backend infrastructure. And basically everything is about running TwinCAT engineering tools in the cloud in the virtual machines, which means customers will be able to have a login on the Beckhoff website, to register there, to log into their dashboard, to see an overview of all the TwinCAT Cloud Engineering instances. And then they can connect to an instance and use the TwinCAT automation software within this instance. But there's not only the instance itself, but there's also the physical connection to the controller hardware. So a secure transport to the physical controller hardware, which means you can also create ADS routes between the physical controller at your machine and the TwinCAT Cloud Engineering instance, so that you can actually do live debugging, you can download software applications, you can do everything that you can also do on-premise and that you have been doing on-premise for the last 20 years. So this is how it looks like. This is how the dashboard looks like when you log in with your user credentials to the TwinCAT Cloud Engineering environment. So basically, like I said, you have an overview of all the TwinCAT Cloud Engineering instances. You can interact with the instances. You can start them, stop them, see metadata of the instance, which means, okay, in which data center is the instance running, which TwinCAT version is installed in the instance, and you can also connect to the instance. And the connection is being done via the web browser, which means you do not need to install any additional software tools. You only require an HTML5 capable web browser, which means you can now also use additional hardware and operating systems that you couldn't use TwinCAT with before. So you can use an iPad for running or for connecting to the instance and for actually interacting with TwinCAT. You can use your iPhone, which makes it kind of hard to interact with Visual Studio on the iPhone, I know, but basically or technically it's possible. So the key benefits of TwinCAT Cloud Engineering is that you can instantiate and operate TwinCAT in the cloud. Sure. So you have all the benefits of the TwinCAT software architecture. You have all the engineering tools available. So CAM Design Tool, MATLAB Simulink, the TwinCAT XAE, Visual Studio environment, of course. You can directly access all these tools via the Beckhoff website. So no additional software components that you need to install on your laptop or desktop PC, that is. You have a simple and secure access to controller hardware, which means you can establish routes between the controller hardware and the cloud instance. And of course, you also have a source control system within each instance to store your TwinCAT projects there, to have them also on-premise installations. So you can use your laptop to connect to the Git repository on an instance to retrieve the TwinCAT projects that have been stored in this repository, which makes collaboration very easy. And you also have an integrated message broker that you can use for data connectivity via MQTT, for example. So I will later also give you a live demonstration. But first of all, I would like to talk more about the use cases behind TwinCAT Cloud Engineering, or use cases that can be addressed using TwinCAT Cloud Engineering. So like I said earlier, the possibilities are endless. So you can solve many, many different use cases with TwinCAT Cloud Engineering. I mean, the use cases that you can solve with TwinCAT itself are endless, right? So with TwinCAT Cloud Engineering, it's the same because it's a regular TwinCAT installation that is running on there. So let's start with a classic use case, TwinCAT engineering. So engineering with a live debugging environment, which means you have here, you see that in this graphics, you have a physical connection with either ADS over MQTT or secure ADS. It depends whether you want to have an one-to-one connection between a controller and an instance, or maybe an end-to-end connection if you have different or multiple instances and multiple controller hardwares. And you want to do live debugging and maybe download new TwinCAT applications down to your machine controller. So you can use TwinCAT Cloud Engineering for that, of course. And together with that, of course, also all the engineering tools available within TwinCAT. TwinCAT Scope, for example. So you can do live diagnostics using TwinCAT Scope. You can use the PLC control to log in to your PLC program that's running on the controller. You can set breakpoints, you can change variable values. So everything that you know from your on-premise TwinCAT workflow, you can also do on a TwinCAT Cloud Engineering environment. I talked earlier about the source control repository. So you can use the integrated Git server to host different repositories to check in or store your TwinCAT projects that you develop on there. And you can also exchange them with on-premise installations, of course, for example, by using either the Git command line client that you see here. So here you see a Git command, Git, where you clone a repository from a TwinCAT Cloud Engineering instance, clone it to your local laptop installation, just by using the public IP address of this instance. And this is, of course, very helpful in collaboration scenarios. But of course, you cannot only use the command line client, but you can use any Git client that you are familiar with. Maybe you want to use the Git client that is integrated into TwinCAT XAE, into the Visual Studio, which is, of course, possible. You can also use the Git client or the graphical user interface from Git itself, which is getting installed together with Git. So different kinds of possibilities, just depending on your personal flavor, of course, and of your application scenario. Of course, we also have an own project compare tool where you can compare TwinCAT projects or check different commits to a Git repository and see what has changed, who has done the change. Maybe you want to revert the change. So there are also tools available within TwinCAT for years that you can also use for that. You can also make use of the relatively new TwinCAT multi-user feature, where you have the scenario that multiple programmers work on the same project, on the same target system. And this TwinCAT multi-user feature is integrating also into the Git repositories of the TwinCAT Cloud Engineering environment, and you can make use of that feature. So here you can see a sample of the history view of this TwinCAT multi-user feature. So you can actually see who has activated a certain version of a TwinCAT project on the physical controller hardware. You can revert the change. You can change into different branches of this project. So the possibilities are endless. So a second scenario or another scenario is the data connectivity and aggregation scenario, where you can use TwinCAT Cloud Engineering. So for example, if you want to aggregate or collect data from different controllers all around the globe, maybe from a Beckhoff controller, maybe from third-party devices, you can have those devices send data to the message broker that's being integrated into the Cloud Engineering instance. And then you can use the TwinCAT runtime that is collecting all this data that's coming in. And maybe you want to transform the data. Maybe you want to present the data in, let's say, an OPC-UA companion specification. Then you would use our TwinCAT OPC-UA server that is aggregating, that is using or accessing all the stored or all the aggregated data and exposing this data in form of a companion specification to the outside world again. So this has been done by us before, so with a very, very early version of TwinCAT Cloud Engineering. So there is this official demo from the VDMA regarding the OPC-UA robotics companion specification, where we used, like I said, an early version of our TwinCAT Cloud Engineering. So this demo of the VDMA was about different vendors providing robotics data via this OPCUA robotics companion specification. And what we did is we had this live Delta robot that we wanted to expose data from. And what we did is we published data from this robot. We published live data to the message broker. We aggregated this data in the TwinCAT runtime. And then we used our TwinCAT OPCUA server to load the companion specification model into its namespace and expose the aggregated data from the live Delta robot. The advantage of this scenario was that we could easily ship the Delta robot to many different places all around the globe, and we only required one internet connection. And we made use of the outgoing data connectivity of MQTT to just publish the data to the message broker, aggregate it in the central cloud engineering instance, and then make this data available via OPCUA, so that the dashboard from the VDMA, which was running on Microsoft Azure, could pick up the data and display the data. So very, very convenient, worked very, very well. And and this is a possible use case. So when you connect the MQTT clients to this message broker, the question is, okay, how do you secure this data communication, right? So what we did is we are deploying a certificate authority in every cloud engineering instance, which is automatically creating and signing certificates for all the MQTT clients. So the first client is, of course, the local TwinCAT engineering, which is running on the instance, because the local TwinCAT should create an ADS over MQTT route to the message broker. And of course, the message broker itself will also have its own server certificate, which has been signed by the certificate authority. And of course, every, let's say, external application that should access or speak with a message broker will also get a certificate that is signed by the certificate authority. This is very handy because every application, for example, that is being compromised can be revoked. So every application certificate can be revoked because we are also managing a certificate revocation list on this certificate authority, so that the message broker will immediately see that a client that is trying to connect via MQTT, that the client certificate has been revoked, so the client is not able to connect to the message broker. So all these certificate management features are available on the cloud engineering instance as well. So this is just an example. So how do you organize all the data? So MQTT is organizing data via so-called topics, right? So you could, for example, create a topic structure, which is having one main topic called machines. Then you have one subtopic for every machine, machine 1, machine 2, machine 3, and every machine will have their own send and receive topics and maybe a description topic. Then you could use our TwinCAT IoT MQTT function blocks to subscribe to the data, to store and aggregate the data in a PLC structure, as you see here. So you see data from the first machine that is coming in, and you maybe want to issue a command that is being sent down to the PLC, and you maybe have some metadata for the PLC device itself, maybe the operating system or the TwinCAT version, etc. So you store and aggregate all this data in the PLC, and then it's very, very easy to expose and make this data available via OPCUA, like you see here. So you will have the data available on the OPCUA namespace. Okay, so another use case would be TwinCAT HMI. So we have, of course, the TwinCAT engine there. We have an optional TwinCAT runtime that we talked about. And of course, you can also host your TwinCAT HMI server on there and also your TwinCAT HMI engineering. So again, you would have a physical connection to controller hardware using ADS over MQTT or secure ADS. And then you can pick up the data from the message broker either via a so-called TwinCAT HMI extension that is picking up the data via MQTT, or the regular way would be so that the TwinCAT HMI server contacts the local TwinCAT runtime via ADS and getting the aggregated data from there. So both ways are possible, and everything can be done on the TwinCAT Cloud Engineering instance as well. Yeah, so like you see here, just a sample TwinCAT HMI visualization based on HTML5. So this is what you see here from the right-hand side that is coming in, a web browser that's connecting via HTTPS to the TwinCAT HMI server to open this HMI dashboard here to see data coming from different machines. Okay, great. So we also have an analytics platform, a product family for analytics, which is called TwinCAT Analytics. And TwinCAT Analytics is not just a software, it's actually a workflow, an analytics workflow. And it enables you to have a location-independent analysis of machine data. And the most important thing is that everything is based on known engineering tools. So you do not need to learn new programming languages or new environments. So everything is integrated into TwinCAT XAE. Everything is being done either graphically or via IEC 61131 function blocks. And it includes, of course, a toolbox with different algorithms and functions so that you can build advanced analytics networks. And then you can automatically create PLC code out of that in order to have a 24/7 analytics runtime that, of course, can be run and executed on this TwinCAT Cloud Engineering environment. So this is what you see here. So we have added a TwinCAT Analytics module here that is getting the data via MQTT from the message broker. Again, data coming in from different physical controllers that are publishing their data. Then you can analyze the data within TwinCAT Analytics. And then you can actually use the one-click dashboard functionality of TwinCAT Analytics to automatically create a TwinCAT HMI project so that you have a visualization within a few mouse clicks. So this is an example of a TwinCAT Analytics workbench. So where you see the analytics network that has been configured here, where you see a TwinCAT scope that has been connected to the analyzed data. And of course, where you see your analytics algorithms here on the right-hand side. And using this one-click dashboard functionality, you can, like I said, automatically create a visualization, HTML5 based, where you see a control, an HMI control for every algorithm within the TwinCAT Analytics. And of course, you can also add your own style. So you can customize the HMI dashboard that is being generated there with your own logo, with your own color scheme, with different languages. So just depending on your use case. Okay, so I would now like to start with the live demo. And what I will show you here is, first of all, the login screen of TwinCAT Cloud Engineering. So you can register at the TwinCAT Cloud Engineering environment. So you can log in with your own user credentials, which I will do now. So, and after you have been signed in, you will see the dashboard with an overview of all the instances that you have created right now. So you will see different instance information. So you will see an ID, which is a globally unique ID for the cloud engineering instance. You will see its public IP address. You will see the usage time. You will see whether it is stopped or started right now. You will see which TwinCAT version has been installed there, whether TwinCAT is in run mode or config mode. And you will also see data like the ADS secure fingerprint, for example, so that you can create a secure ADS route to the cloud engineering instance. Everything so that it is very convenient for you to connect your physical hardware to the cloud engineering instance. Of course, you can also create a new instance here. So you can select different kinds of parameters, for example, the instance size, where you can select at the moment from 3 different sizes, small, medium, large, just depending on the performance class of your virtual machine, whether it should have 2 or 4 or 8 CPU cores, or 4, 8, 16 gigabytes of RAM. And you can select what kind of base image should be used for the instantiation of this virtual machine. For example, whether you want to have a TwinCAT 4022.30 or whether you want to have a TwinCAT version 4024.10, which is what I select right now. So I click on create, and now the provisioning process is started, and this process takes about 4 to 5 minutes. And after this time, the virtual machine is fully provisioned. You will have TwinCAT XAE running on there. You will have all the functions running on there. So everything being done after 4 or 5 minutes. So, but we do not want to wait for this right now. I just want to show you what happens when you click here on the connect button. So when you click on the connect button, we open a new web browser window, and we will tunnel the remote desktop connection through the web browser. So now you can work with this Windows environment here, just as you would do with your regular laptop. So you will have your Windows Explorer, you will have the command line, and of course, TwinCAT itself too. So I have prepared a short demo here that I want to show you. So I'm starting TwinCAT XAE now. I'm loading a project, and this project will have actually two functionalities. One is it will create a random running light, which means it will create some output data for digital outputs, and it will create also a sine wave that we want to scope in a few minutes. And what I want to do is I want to activate this project now on a physical hardware that I'm connected to right now. So I'm connected to CX5130 right now, which is running our newest operating system, TwinCAT BSD. And this CX device, which you will see right now in the video feed, this TwinCAT device is actually connected to this message broker here that is running in this instance via ADS over MQTT. And the communication is being secured via TLS using client server certificates. So now I want to activate this project here because, yeah, I'm connected to the hardware. So I'm activating this project right now. Now it's being compiled in the background, so you know all that better than me. It's being compiled in the background for the hardware platform. And then it's asking me whether I want to restart TwinCAT in run mode now. I say yes. And now you will see that the program has been activated on the device. So I need to look for that. Yep, that looks good. So the output data is there. So the program has been activated. And now I want to scope some variable values from this CX device. So I'm using the target browser for that. So first of all, I have a scope project here that I have added. So I have a scope YT project, 2 channels, 2 charts actually, and now I want to connect some data to it. So I'm now using the target browser to browse into my CX device. I see the local PLC runtime. I see that there is a function generator here, and I will select my sine wave signal. So I'm dragging this to this chart. And now I want to see some of the outputs, or one of the outputs, which I will find here somewhere deep hidden there. So I'm dragging this to my second chart. And now I'm starting the scope. And now I will actually see, I'm scoping the live data from the CX device. It doesn't look very complex, but I think the complexity is within the data communication actually, because all the signals are being transmitted from here, Wörl, to the data center, which is running in Frankfurt, so 300 kilometers to the south. And everything is happening instantaneously, right? So there is no, or a very small delay only, and it really makes it very convenient and very comfortable to work with this TwinCAT Cloud Engineering instance. Okay, so I'm switching back to the presentation right now. So I would like to talk about the roadmap a few more minutes before I'm finishing this presentation. So we did our product announcement in November 2019, and we started an internal beta 1, in June this year, so a couple of months ago. And now a second internal beta version for every Beckhoff colleague will be available in September, so next month. So we want to get a feeling for, okay, how does the backend infrastructure perform and feel like when there are hundreds of different people working with it at the same time? So we want to have a feedback for that as well before we are starting to release this cloud service. And then we will have a beta for selected customers in October. And of course, a public beta will follow shortly after, so probably around December. It depends a little bit on the feedback that we receive from the internal beta version and from the selected customers, but we expect to have a release available early 2021, maybe earlier. It depends on some more development milestones in the background. But I'm very positive that it will be early 2021 and not late 2021. Okay, so if there are no more questions left, then I would like to thank you for your time. I wish you a wonderful week, and thanks for listening and thanks for watching. Bye-bye.